Hello everyone, welcome back to Logic section. So here's how we're going to do this online sessions. There is a handout that goes with the video. And as we did in our normal classes, we're going to work on the problems that are on the handout. Some of them I do, and the other ones I ask you to work on them. And then I do them and explain them. So when I ask you to do a problem, you should pause the video and work on it at your own pace. And then you can play the video and see whether you did it right. It is very important that you work on the problems when I ask you, because that's the way that you learn. You won't get much out of these videos by watching them passively. So get a pen and paper, download the handout and have it in the background and follow along. So today we are going to work on some symbolization problem in first order logic. And the first topic that we're going to talk about is the topic of restrictor predicate and main predicate. Okay, so look at the first sentence on the left. Something is heavy. And the domain of symbolization is domain of things. Notice that this sentence is not limited to anything within the domain. We're just saying something, and it could be anything in the domain, is heavy. So we simply symbolize it as there is some x, and x is heavy. But contrast that to the sentence on the right, some chairs are heavy. Now the sentence is about chairs. You're talking about a group of things, a particular group of things within the domain of things, namely chairs. So chairs are called restrictor predicate. And what we say about them, some of them are heavy, is going to be the main predicate. And when you're dealing with an existential quantifier, the restrictor and the main are connected to an and. So the way we symbolize the sentence is that there is some x, such that x is a chair and x is heavy. We have the same concepts with universal quantifiers. So let's look at these sentences. Everything is heavy. On the left, again notice that this is not restricted to anything within the domain of things. It's not about any particular group of things. So there is no restrictor predicate here. We simply symbolize it as for all x, x is heavy. But every chair is heavy, the sentence on the right, it's restricted to chairs. We are talking about a particular group of things, namely chairs. So the chairs are going to be our restrictor predicates. And heavy is going to be the main predicate. The main predicate is always the main verb phrase of the sentence. And when you're dealing with a universal quantifier for all x or every, the restrictor and the main are going to be connected through an arrow. The restrictor goes at the base of the arrow and the main goes at the end of the arrow. And the order matters. If you don't get the order right, your symbolization is going to be wrong. Okay, so notice that when you're dealing with existential here, for some x, cx, and hx, the restrictor and main are connected through an and. When you're dealing with a universal, the restrictor and main are connected through an arrow. Okay, now consider this sentence at the bottom. Everyone is happy. We can use the domain of people to symbolize it, or we can use the domain of things to symbolize it. If we use the domain of people, everyone is happy is not restricted to anything within the domain, right? We are not talking about any particular group of people, so there is no restrictor predicate if you're using the domain of people. So you can simply symbolize it as for all x in the domain of people, x is happy. But if you want to use the domain of things to symbolize everyone is happy, now, using the domain of things, the sentence is restricted to a group of things, a particular group of things, namely people. And you need to make sure that you build that restriction into your symbolization if you're using the domain of things. So using the domain of things, we symbolize this as for all x, if x is a person, px, then x is happy. So using the domain of things, we need to build the restrictor predicate people or person into our symbolization, right? So to be clear here, P stands for X is a person. Okay, so let's do some practice. We're going to go to handout. So the first problem on the handout is that some rich famous artists live in New York. So we're going to symbolize this. Notice that we have some, so we are going to use existential quantifier. And the sentence is about rich famous artists. So this is our restrictor predicate. And about them, we're saying that they live in New York, some of them. So this is going to be our main predicate, which is the main web phrase. And these two things, restrictor and main, are going to be connected to and because we have an existential. So here is what we symbolize it using the domain of things or people. It doesn't matter in this case. So we're saying that there is some x. Then we're going to have the restrictor predicate first, and then and we're going to connect it to the main predicate, right? So that's the overall structure. Now the restrictor predicate is rich famous artist. So there are three parts to it that needs to be connected to ands, and it's important that we group them. Okay, so we have there is some x such that X is rich and X is famous and X is an artist. Now we need to group these series of ands, and we can do it by putting parentheses around these two, or you can put parentheses around F and A. It doesn't matter. That would be our restrictor predicate. We have an and we connect this to the main predicate, which is live in New York. So it's a simple predicate. We use L for that X. So there is some X such that X is rich and famous and artist, and X lives in New York. And as I said, the domain could be things or people. It doesn't matter. Okay. Sorry. Now you try the second one on the handout, which is this one. Some rich artist who lives in New York is neither talented nor famous. So here is where you pause the video and you work on the problem on your own and try to identify the restrictor and the main. So again here, notice that we have some, so we are going to use an existential quantifier, and we are talking about rich artist who lives in New York. That is a restrictor predicate. And about rich artist who lives in New York, we're saying that some is neither talented nor famous. So that is going to be our main. So the overall structure is that restrictor and the main are going to be connected through an and. And restrictor has rich artist and live in New York. So those three things need to be connected through a series of ands, and they need to be grouped. So we can do it this way. There's some X is rich, X is an artist, and X lives in New York. Then use an and connect that to the main. That X is neither talented nor famous. And you can do it using a conjunction, not TX and not FX, or you can do it using a disjunction, putting the negation outside the parentheses. And notice that I'm using a square brackets just because it's hard to draw normal brackets or parentheses. So I'm going to use a square brackets. Okay, so let's move to the next problem. Now here we have every black cat is fairy and cute. Now the first thing to notice, we have universal quantifier. And the sentence is about black cats. So this is our restrictor. And about them, we're saying that every one of them is fairy and cute. So this is going to be our main predicate. And remember that when you have a universal restrictor and main are connected through an through an arrow. So here is how we symbolize this. We say there is for all x, Then the restrictor goes first, then we're going to have an arrow, and then we're going to have our main. So this is the overall structure. Now let's deal with the restrictor. Black cat, so X is black and X is a cat. And now let's deal with the main, fairy and cute. So X is fairy and X is cute. I'm going to use U for cute because we already have C for cat. Okay, so for all X, if X is black and if X is a cat, then X is fairy and X is cute. So that's how we symbolize this every statement. So the domain is going to be the domain of things, obviously, because we are talking about cats. Okay, moving to the next one. Now you try this one. So pause the video and try to do it at your own pace. So here we have every, and we have fairy black cat as a restrictor, and we have cute mammal as the main. So here is how we symbolize it using the domain of things. So we say that for all X, if X is a fairy black cat, so we need to connect those three things. X is fairy and X is black and X is a cat. And notice that now we need to group things inside this parentheses here. So we can do it this way, or you can use parentheses around B and C, doesn't matter. So that would be a restrictor. Then we're going to use an arrow because we are dealing with a universal and connect it to the main, which is cute mammal. So let's use U for cute. X is cute and X is a mammal, and close the whole parentheses. Okay, so that's how I symbolize this. Okay, moving to the next one. So you try this one. So we have everyone who attends the class but doesn't pay attention will either drop or fail. So using the domain of people, because let me put it here, the domain is going to be people. We have every, so we are going to use a universal. And here the restrictor is everyone who attends the class but doesn't pay attention. That whole thing is the restrictor predicate. And the main predicate is they will either drop or fail. And since we have a universal, we know that these two things, the restrictor and the main, are going to be connected to an arrow. So let's get the whole sentence here. So there is for all X, and we start with the restrictor. We want to say that X attends the class but doesn't pay attention. X does not pay attention, so that's a negative statement. We need to use a negation. Then we use an arrow, and then we symbolize the main predicate. Will either drop or fail. X drops or X fails. So I use D for drop and F for fail. Let's do the next one. Every talented singer will improve if they practice. So here we have a statement that uses a universal, and it's about talented singers. So that is the restrictor. And the main web phrases that will improve if they practice, right? So this is going to be your main predicate. And these two things are going to be connected through an arrow. So that's the overall structure. So let's actually do it here. So we're going to say for all x in the domain, and the domain could be people or things. We know the singers are people, so you can use the domain of people. But since people are not explicitly mentioned here, you can use domain of things if you want to. So for all x, if x is a talented singer, right? X is talented and x is a singer, then now here for the main predicate we're going to say that x will improve if x practices, right? This is an if statement, and the part that goes after if practices goes at the base of the arrow, and improve goes at the end of the arrow. So for all x, if x is a talented singer, then if x practices, x will improve. Now you try this one. Okay, so we have every, and we have talented artist. That is our restrictor. We're talking about this group of people. And about them, we're saying that it's rich only if they're famous. So that's the main. And we know that these two things are going to be connected to an arrow because we're dealing with a universal. And the domain could be things or people. So let's do it here for all x. If x is a talented artist, if x is talented and x is an artist, then so we're going to use an arrow and the main predicate. Now here for the main predicate you want to say that x is rich only if x is famous. So x is rich only if x is famous. Remember that everything that goes after only if goes at the end of the arrow. So for all x in the domain, if x is talented and x is an artist, then if x is rich, then x is famous. That's how we read it. So just remember that P only if Q is symbolized in this way, and P if Q is symbolized in this way. Okay. So the last one for this section, all mushrooms which are deadly if touched are also deadly if eaten. So this one is interesting. It needs a little thinking. You might not immediately see what's the restrictor and what's the main. So let's think about it. We have all, so we are dealing with a universal. So what is the sentence about? It's about mushrooms which are deadly if touched, and about them we are saying that they are also deadly if eaten. So the restrictor predicate here is this whole thing, mushrooms which are deadly if touched. And the main predicate is, you can always remember it's going to be your main verb phrase. So this is going to be your main predicate, and these two things are going to be connected to an and. So let's do it here, and the domain is domain of things, obviously. So we're saying that for all x, and then we do the restrictor, if X is a mushroom and X is deadly if touched. So X is a mushroom and X is deadly if touched. So here you want to say deadly if touched. So that whole thing is your restrictor predicate. Then you have an arrow and you connect it to your main predicate. And here now your main predicate is deadly if eaten. So this time eaten is the thing that goes after if. So eaten is the part that goes at the base of the arrow. If X is eaten, then X is deadly. Okay, so I'm using M for mushroom, T for is touched, D for is deadly, and E for is eaten. And the domain is the domain of things. Okay, so here we have, for the second part of the handout, we have some negative statements, a statement that involves negation, and we're going to symbolize them once using existential and once using universal. So let's start with the first one. No dentist is a basketball player. So it's basically to say that no dentist is a basketball player is to negate that there is some dentist who's a basketball player, right? So we can symbolize this in this way. It is not the case that there is some X such that X is a dentist and X is a basketball player, right? We can say the same thing using a universal quantifier. To say that no dentist is a basketball player is basically to say that every dentist is not a basketball player. So we can symbolize this equivalently in this way. For all X, if X is a dentist, then X is not a basketball player. And these two things are equivalent. So you try the next one, try to symbolize it once using an existential, once using a universal. So here we have not every private university has a softball team. So notice that this is just the negation of a universal statement, not every. So not, and then you want to say every private university has a softball team. So it is not the case that for all X, and the restrictor is private university. So if X is private and X is a university, then X has a softball team. Let's use H for X has a softball team. Right? This is the straightforward symbolization using a universal. But we can say the same thing using an existential. To say that not every private university have a softball team is to say that some private universities don't have a softball team. So we can use, we can symbolize this using existential in this way. There is some X such that X is a private university and X does not have a softball team. Okay, you try this one. No smuggy city is unpolluted. Okay, now we can do this using a existential first. To say that no smuggy city is unpolluted is the negation of the claim that some smuggy cities are unpolluted. So it is not the case that there is some X such that X is a smuggy city, X is a smuggy and X is a city, and X is unpolluted. Notice that unpolluted is the negation of polluted. So I use P for X is polluted and I negate it. Okay, so it's not the case that there is some X, that X is a city and X is a smuggy and X is not polluted. Okay, how should we say this using a universal? To say that no smuggy city is unpolluted is basically saying that every smuggy city is polluted, right? So we can say it in this way as well. For all X, if X is a smoggy city, then X is polluted. So again, the key is to recognize that smoggy city is the restrictor and is unpolluted is the main, and then you can figure out how to symbolize these things from there. Okay, not all famous artists are rich and live in New York. So we have the negation of a universal. So that's a straightforward way to do it. So let's do that. It's not the case that for all X. So the restrictor is that X is a famous artist, right? X is famous and X is an artist. Then we use an arrow connected to the main, which is this thing here. So, rich and live in New York. So X is rich and X live in New York. Okay, that's symbolization using a universal. Now, to do it with the existential, so this is equivalent to say that some famous artist is not rich and live in New York. It's not both of those things, right? So we symbolize it in this way. There is some X such that X is a famous artist, right? And remember, in existential, the restrictor and main are connected to an and X is not both rich and live in New York. Or equivalently, for this part, you can say that X either is not rich or does not live in New York. Right? So the sentence is basically saying that not all famous artists are both of these things, rich and live in New York. So what you want to say is that there is some famous artist that is not both of those things, right? So the negation should go outside the parentheses. Okay, so let's move on. We have some more examples. I'm going to skip them to the next topic, quantifier scope. Okay, so let's look at these two sentences and try to symbolize them. Some cities are smoggy and some are overpopulated. So here notice that we have two some and they are connected through an and. So the overall structure here is a conjunction of two existential claims. So we need to symbolize that in a way that reflects that structure. So the first conjunct is some cities are smoggy. So we say that there is some X such that X is a city and X is a smoggy. Right? And then we use an and connect that to the second sentence, that some cities are overpopulated. So there is some X such that X is a city and X is overpopulated. So I use O for that. Okay, so let's contrast this with the second sentence here. Some cities are smoggy and overpopulated. Now here notice that we are dealing with an existential claim. And the existential claim is about cities, and about them we're saying that they are smoggy and overpopulated. So this is our restrictor and this is our main, and we know that they are going to be connected through an AND. So the second one is symbolized in this way. There is some X such that X is a city and X is smoggy and overpopulated. So this is how we symbolize the second one. Okay, now here we can see the notion of the scope of a quantifier. So the scope of the quantifier is the formula that is immediately to its right. So if you look at this first conjunct in the first sentence, the formula that is immediately to the right of the existential quantifier is this thing here. So we say that the scope of this quantifier extends all the way to here. Then we have an and then we have another quantifier, and the formula and the scope of this quantifier extends up to here. And these two things are connected to each other through an and. Okay, so the main connective in this first sentence is an and, so we are dealing with a conjunction. In the second sentence, the formula immediately to the right of the existential quantifier is this whole thing. So the scope of the quantifier extends up to here. And notice that this second sentence is an existential sentence. The main connective is the existential quantifier. So in the first one, we have two existential connected through an and. So the last thing that we put in was and, so that's a conjunction. In this second sentence, the whole thing is in the scope of the existential quantifier. So we have an existential sentence. So that's the notion of the scope. Now all the variables that are in the scope of a quantifier are bound, we say they are bound by that quantifier. So here, this variable and this variable, they are bound by this quantifier. Here, this variable and this variable, they are bound by this quantifier. But in the second sentence, all the variables are in the scope of the existential, so all these variables are being bound by this quantifier. Now, these are some important notions that we're going to use later, but it's good to keep an eye on them to get, because they're going to become very important later. So you try to symbolize these two sentences and try to pay attention to the scope of the quantifiers that you're using. So for number 3, we have some polluted cities are smoggy. Notice that we have only one existential quantifier. Or restrictor is polluted cities, and about them we're saying that they are smoggy. So there is some X such that X is polluted and X is a city, and X is a smoggy. Let's do number 4. So here we have some polluted cities are smoggy and some aren't. So notice that we have two some connected to an and. Okay, so we're going to have a conjunction. The first sentence is that the first conjunct is that there is some X such that X is a polluted city and X is a smoggy, right? That's the first existential. Then we have an and we connect it to the second, some aren't, which basically is saying that some polluted cities aren't smoggy. So there is some X such that X is a polluted city and X is not smoggy. Okay. Now let's think about the scope. So here we have the formula that is immediately to the right of the existential is this whole thing here. So the scope of the existential extends up to here, and all of these are being bound by the same quantifier, namely this one. In the second one, the scope of this existential extends up to here because this is the formula immediately to its right. And then we have this other existential, and the scope of this extends to here. So these variables are being bound by this existential quantifier because they are in the scope of that quantifier. And these variables here are being bound by this existential quantifier. Okay, so normally when you're dealing with a sum, you're dealing with an existential, but not always. There are some weird cases where you have a sum in the statement, but you are dealing with a universal. So here's an example, here's an example of that. So a mushroom is deadly just in case it is poisonous. You might think that there is a or some, so we are dealing with an existential, but that's not the case. That is not the case here. If you really think about the meaning of the statement, it's a universal statement. It's not about just some particular mushroom. It's not about at least one mushroom. It's a general statement or a universal statement about mushrooms. It is telling us that every mushroom is deadly just in case it is poisonous. So we are going to use a universal quantifier to symbolize this, even though we have a mushroom, which might give you the idea that this is an existential, but if you really think about the meaning, we are dealing with a universal. So this is a case of universal sum or universal A. So we are saying that all mushrooms are deadly. Just in case poisonous. So let's symbolize that. So for all x, the restrictor predicate is mushroom. This is a statement about mushrooms. So for all x, if x is a mushroom, then, and the main predicate is that it's deadly just in case it is poisonous. Now, if you remember from twist functional logic, just in case is a biconditional statement. It means basically if and only if. So we are saying that it is deadly if and only if, just in case, x is poisonous. And the domain is going to be the domain of things. Okay, you try this one. So here we have, if someone is honest, they won't plagiarize. So again, you might think that this is an existential because we have some, but if you think about the meaning of the statement, if someone is honest, they won't plagiarize, we are saying that everyone who's honest won't plagiarize. So we are dealing with a universal statement. So we are going to symbolize this as, for all x, if x is honest, then they won't plagiarize, right? Then x won't plagiarize. And here we need, the domain has to be the domain of things. Sorry, the domain of people, because we have someone. Right? So this is a case of a universal someone. Notice that someone is occurring in the antecedent of a conditional statement in the English, but the overall structure of the logical structure of the sentence is basically a universal. Okay, try this one. So if a musician is talented, then they will succeed. Again, notice that we are not talking about some particular musician, or at least one musician. We are talking about musicians in general. So we are saying that every musician who's talented will succeed. So if you're going to symbolize this as a universal statement, we're going to say for all x, and the sentence is restricted to talented musicians. So for all x, if x is a musician and x is talented, then we use an arrow to connect it to the main, and the main is that x will succeed. The domain could be things or people. So again, that's a case of a universal sum or a universal A. This is not a sentence about at least one musician. This is a sentence about all musicians. So when you have a sum statement or an A statement that happens in the antecedent of a conditional, that's a sign that you're dealing with a universal statement. Okay. Now, every and any normally mean the same thing, and they mean a universal statement, right? So that's the case normally, but there are some cases where every and any mean different things. So let's look at sentence 4 and 5. In sentence 4, we have everyone gets an A. If everyone gets an A, Mike will be happy. In the second one, we're saying that if anyone gets an A, Mike will be happy. They are saying different things. So number 4 is telling us that the sufficient condition for Mike being happy is that everyone gets an A, right? But number 5 is telling us that the sufficient condition for Mike being happy is that just someone gets an A. And right, if there's one person that gets an A, Mike will be happy. So those are different statements. They are both conditional statements. So we're going to use an arrow to symbolize each one. But in the first one, the antecedent is a universal. So we're saying that for all x, if x gets an A, then Mike will be happy. But in the second one, we're saying that if there is someone that gets an A, Mike will be happy. So the antecedent is going to be a conditional. If there is some x such that x gets an A, then Mike will be happy. So those are quite different statements. So here is a case where everyone and anyone mean different things. They normally mean the same thing, but in this case, they mean different things. Okay, so notice that the scope of this universal, the formula that is immediately to the right of the universal, is gx. So the scope of the universal extends to here. And then we have an arrow, and then we have hm. So the main connective here is this one, conditional. So the statement is not a universal statement, it's a conditional statement. The same thing here, the scope of this quantifier extends to here, and then we have a conditional that connects the universal to hm. So again, the sentence is not an existential, it is a conditional statement. Because arrow is the last thing that we put in order to construct this sentence. Okay, you try number 6. So if any band members plays well, Andy will be satisfied. So again, the sentence is saying that if there is at least one band member that plays well, Andy will be satisfied, right? So again, this is a case where any needs to be symbolized as an existential statement. So we are saying that the whole statement is a conditional. The antecedent is that if there is someone, there is some band member, if there is some x such that x is a band member and x plays well, then Andy will be satisfied. Sorry, let me use S for satisfied. Right? So if any band member plays well, if there is at least one X such that X is a band member and X plays well, then Andy will be satisfied. And again, here we are dealing with a conditional statement. The scope of this existential extends to here. Then we have arrow connecting these two parts. So again, we have a conditional. Okay, so in the last part of the handout, we deal with two-place predicates. We're kind of running out of time, so I'm not going to do all the problems that are in this section. We will do those that are left next week. So let's see how far we can get. So far we have been working with one-place predicates, things like is happy, right? The predicates that only take one name and produce a whole sentence. So for example, blank is happy is a one-place predicate because all it takes is one name to make this into a whole sentence. For example, you can put Andy here and get a full sentence. Andy is happy. Right? But there are things like love or respect, and these are two-place predicates. So look at the sentence here. Alex loves Becky, but Becky doesn't respect him. So here we have the predicate love and we have the predicate respect, and these are our relations. These are things that take two names in order to produce a sentence. So we can use L for blank loves blank, so we call it a two-place predicate. The same thing with respect. We can use R for blank respects blank. Okay, now we have the name Alex and Becky. So let's use A for Alex and lowercase b for Becky. Okay, how should we symbolize this? Notice that there is no quantifier. It's a simple statement. We have Alex loves Becky connected through an and to Becky does not respect him. So here is we say Alex loves Becky. L A B. Then we have but Becky doesn't respect Alex. So RBA says Becky respects Alex, and we just negate it. Okay? So this would be the symbolization for this sentence. And notice that order matters. LAB means Alex loves Becky, but LBA means Becky loves Alex. So LAB is not the same things as LBA. The order matters. Okay, so now let's do some practice with two-place predicates and quantifiers. This is where things start to get a little more challenging. So look at this sentence. Someone is taller than both Adam and Sid. So we have the predicate taller than, which is a two-place predicate. Let's use T for that. And then we have Adam. Let's use A for that. And we have Sid. Let's use lowercase c for that. And the domain should be the domain of people. So if you're saying that there is some X such that X is taller than Adam and X is taller than Sid, right? So there is some X such that X is taller than Adam and X is taller than Sid. So notice that T takes two names or name and variable in order to produce a sentence. There are two arguments for T. And the domain is people. Okay, Jan likes some blockbuster movies. So how should we symbolize this one? Well, notice that we have some. So we're going to use existential quantifier. What is the restrictor here? What is the group of things that we are talking about? Well, we are talking about blockbuster movies, right? So that's what the sentence is about. So this is the restrictor predicate. And what we're saying about blockbuster movies is that Jan likes some of them. So this is going to be, oops, what happened? This is going to be the main predicate here. Okay, so remember that restrictor and main are going to be connected through an AND. So we're saying that there is some X such that X is a blockbuster movie. So X is a blockbuster and X is a movie. And then we use an AND to connect it to the main predicate. And the main predicate is Jan likes X, right? So like is a two-place predicate. Jan goes first, X goes second. Jan likes X. And that would be the symbolization. And the domain is obviously the domain of things. We're talking about movies, blockbuster movies. Okay, let's do the next one. So here we have Becky loves someone who doesn't love her. So you try this one. So notice that we have someone, so we are going to use existential and the domain of people. And the restrictor predicate, the thing that the sentence is about, is that the sentence is about someone who does not love Becky. So this is going to be the restrictor predicate. And about this person who doesn't love Becky, we are saying that Becky loves it, or Becky loves it, her, whatever. So this is going to be the main. Okay, so in order to symbolize this one, we're going to use an existential quantifier. There's some X. And the restrictor is that X does not love Becky, right? So for the restrictor, it is not the case that X loves Becky. That's a restrictor. Then we use an AND to connect that to our main predicate, which is that Becky loves X. So loves Becky X. So that would be the symbolization. I should have used black. Okay. Yep. So, and the domain is going to be the domain of people because we have someone. So let's move on. Let me skip this one. Yeah, okay, so Mr. King selected a player who's faster than Sam. So we notice that here we have a player or some player. So we are dealing with an existential. And the restrictor predicate is that a player who's faster than Sam. And about this player, we are saying that Mr. King selected this player. So this is going to be the main predicate. Okay, so let's symbolize it. There is some X in the domain of either things or people, doesn't matter here, such that X is a player who is faster than Sam. So we have two pieces of information. X is a player and X is faster than Sam. So we are going to have a complex restrictor predicate. We're saying that X is a player and X is faster than Sam. For Sam, we cannot use S. We can only use lowercase a through R. So let's use M for Sam. And then we use an AND to connect this to the main predicate. And the main predicate is that Mr. King selected this X, right? So let's use S for selected. And the one that did the selection is Mr. King. Let's use K for Mr. King. That's we're treating that as a proper name. And we're saying that Mr. King selected X. So there is some X such that X is a player and X is faster than Sam, and Mr. King selected X. Okay, let's move on. Okay, this one is a little difficult. I'm going to skip this. Maybe next week we do that one. Okay, let's do this one. This is a universal. We have everyone, so we are going to use in a universal. And the sentence is about, we're talking about everyone who likes Alex but not Becky, right? That's the restrictor. And about this group, we're saying that they like Sid. So this is going to be the main predicate. And remember, when we have a universal, restrictor and main are going to be connected through an arrow, right? So let's do the symbolization. So, and the domain here is going to be the domain of people, because we have everyone. So for all X in the domain of people, if X likes Alex but not Becky, right? That's the restrictor. So X likes Alex, but X does not like Becky. Then we use an arrow. And the main predicate is that X likes Sid, right? So likes X Sid. That would be the complete symbolization using the domain of people. So for all X, if X likes Alex and doesn't like Becky, then X likes Sid. Okay, let's do this one. Becky loves everyone. You try this one. Becky likes everyone who respects her. So we have everyone. We're going to use a universal, and we're going to use the domain of people. And the restrictor is that everyone who respects Becky, we are talking about this group of people. And about them, we are saying that Becky likes them. So this is the main predicate. Okay, let's symbolize this. Remember, these two things are going to be connected through an arrow. So we have for all X, if X respects Becky, right? X respects Becky, that's the restrictor. And then we're going to use an arrow. And we're going to connect it to the main, that Becky likes X. So that would be the symbolization for that one. Let's do one more. We've gone a little bit over time, but it's okay. The next time I'll try to get it right. So every player who's faster than Alex has a chance. So let's use F for faster faster than, blank is faster than blank. And let's use has a chance as a one place predicate. So we use H for that. And we have A for Alex. Okay, so if we're going to use a universal for all X, and the restrictor is player is faster than Alex. So there are two pieces of information here. X is a player, X is faster than Alex. Right? So X is a player, so let's use P for is a player. Right? So X is a player, and X is faster than Alex. And about this player who's faster than Alex, we're saying that has a chance, right? So that would be the symbolization. Okay guys, that's it for this week. Sorry we went a little over time.
Bye-bye.